Orthographic projections of inclined, curved and oblique cut surfaces in a cube. In this video, we will learn the basics of orthographic projection by taking three examples. Example 1. A cube cut by an inclined plane which is perpendicular to one of the cube surfaces. 2. A cube cut by a curved surface. And 3. A cube cut obliquely by an inclined surface. This is a cube with 6 faces of exactly same dimensions. Each face is parallel to one and perpendicular to the remaining 4 faces. So, example 1, a cube cut by an inclined plane. So, we will show you how the plane passes through the cube. So, actually the plane cuts 4 edges halfway. So the cutting plane passes such that it removes one edge of the cube completely and cuts through the midpoints of other 4 edges. The marked black lines show the new edges that will be created as a result of this cut. So this is the 3D view of the cube after sectioning or cutting. These are the edges of the cube, and this part has been cut, so new edges has been created. We can try to see how the cube looked before cutting by drawing the edges of the cube with a pencil. So this part along with one of the edge was removed by sectioning. So we will take this face or this direction as the front view of this object. So a proper isometric view of the object is shown here. So we will take this direction as the front view, and the view from the top will give us the top view. On the left side, we will see the left hand side view. So this is a complete isometric view of the object. Edges of the cube are 40 mm long, and the cutting plane meets the edges midway at 20 mm from both ends or the corners. So now we will draw the orthographic projections of the cube in the first angle projection system. First we draw the reference line, and then we will draw the front view above the reference line. Because this is in the first angle projection system, and we assume that the object is kept on the HP. So the side of the cube is 40 mm. So these are the outer edges of the front view. So in the front view, we will see this part. The inclined part will be projected in the front view. So we will not see the true dimension of the inclined part, but rather the projections of it. So there are 4 new edges created as a result of cutting. One will be seen horizontally 20 mm above the bottom edge, and the second new edge is basically the top edge. So let's draw one of the new edge in the front view. So this will be 20 mm above the baseline. So this edge will be seen in the front view. So this is the new edge which has been created. These sides, this side which is the new edge is projected. So we see the projected length. This is also projected, and we see the projected length. So now we will draw the top view below the reference line. So this is the outer edges of the top view. So in the top view we will see a rectangle, this part, and the inclined part will be projected. So inclined part will not be true length but rather projected dimension. So one of the new edge will be shown here, 20 mm from the baseline. So this inclined part has been projected as a rectangle. This inclined edge is shown as a straight line. Both of them are in projected length. So this is the top view and this is the front view. Now we will draw the left hand side view on the right side of the front view. So this is another reference line x1, y1, and we draw a line which is 45 degree to the reference lines, and we will project all the dimensions from the top view up for the left hand side view. So using the 45 degree line we can project the dimensions from the top view for the left hand side view, and from the front view we can directly project the dimensions. So now we can check for the sides and the corners of the left hand side view. So this side in the front view and the same side in the top view will match together. So this is the point. And that point, this side in the front view and this side in the top view, they will match together. This point represents the corner, as you can see with the arrow. Now that side in the front view and same side in the top view, so they will be matched together, and this is the point. So this point represents this corner in the left hand side view. So the two corners have been found. We will connect these two corners in the left hand side view, which basically represents the inclined edge. And now we will complete other edges of the left hand side view. So this makes the complete left hand side view of the cube. Now we should do the dimensioning after this. So this dimension will be 40 mm. That's every edge of the cube is 40 mm. This edge is also 40 mm. This dimension will be 20 mm each, because the inclined plane cuts one of the edge at midpoint. So 20 mm and 20 mm. Similarly here also this dimension will be 20 mm and 20 mm because the cutting plane cuts this one of the edge midway. So now example 2, cube cut by a curved surface. So instead of a plane passing through, we will see how the cube will look like if a curved surface cuts the cube. So this curved surface has a radius of curvature, and this curved part has a length. So radius of curvature and the length. Length will be same as edge, length of the edge, which is 40 mm. And radius of curvature will be 20 mm because this is cutting the edge midpoint. So radius of this curvature is 20 mm and length of this cut is 40 mm. So this cut removes a quarter of a cylinder from the cube, creating new edges at the faces of the cube. So this is the isometric view of the cube after sectioning. So we can see how the cube looked like before cutting. So this part was removed and there is a curved surface in the cube. So it has a curvature of 20 mm and is 40 mm long. So now we will use this direction as the front view, and the top view will be from the tops. This side will be the left hand side view. So 3D view of the cube cut by a curved surface, as explained before, is shown here. The sectioning plane has created a curved new surface of radius of curvature of 20 mm. So this is one of the edge of the cube, which is 40 mm, and the curved surface cuts this edge midway, so this dimension is 20 mm. This is also 20 mm. And the radius of curvature of this curved surface is 20 mm. So now we will draw the orthographic projections of the cube which has been cut by a curved surface. So this part will be seen in the front view and the curved part will be seen as a projected rectangle. So in the front view we will see two rectangles. So we draw the front view first. So 40 mm, the base. So this makes the outer edges of the front view. But this front view is divided by a line which is 20 mm above the baseline. This line actually represents the new edge which has been created because of cutting. 20 mm from the baseline. Okay, so this is the front view. So the base is represented. The top part is also represented. And the curvature part is represented as a rectangle. So this is the new edge. The top edge is also a new edge because of cutting. The curved part is projected as a straight line. On both sides, the curved part is projected as a straight line. So the front view is complete. Now we will make the top view. So this is the outline of the top view. So the top view will be a square, and there will be a line which divides this into two parts, and this line basically represents the new edge. The curved surface will be again projected in the top view, and it will be seen as a rectangle. So this is 20 mm. So midway we will draw a line which represents the new edge. So now we can see that this side corresponds to the back side. This corresponds to the new edge which has been projected, and this is the new edge in the middle. And the curved part is projected as a straight line of this length, straight line of length 20 mm. So the top view is ready. Now we will draw the left hand side view using the 45-degree angle line. We will transfer the dimensions of the top view using 45-degree line and those of the front view. So these are construction lines, so they should be drawn as thin lines. Now we will identify the sides and the corners in the left hand side view. So this edge in the front view is this line, the top line. Same edge in the top view is this middle line. So the top line and the middle line extensions, we find this point which represents the corner, this corner on the cube. Now the other corner we can identify. So this is the front view, the middle line, and in the top view this line is represented at the bottom. So extensions from these two so this is the point which represents the corner, the second corner. So now we have identified two corners in the left hand side view. So using these corners we will draw an arc of 20 mm radius, because the curved surface will be visible in the left hand side view in its true dimension. So this is an arc of 20 mm radius, and this basically represents the curved surface. So in the left hand side view we are able to see the curvature of the curved surface. Now we can complete the rest of the left hand side view. Okay, so left hand side view is ready. Front view, top view and left hand side view placed on the right side of the front view. Now we can do the dimensioning. These dimensions will be 20 mm each, because the curved surface is cutting the cube edge midway. This is 40 mm. This dimension gives us the dimension of the radius of the curvature. So in these two examples we saw the orthographic projections of a cube with a flat inclined cut and with curved cut surfaces. So the cube was cut such that one edge of the cube was removed, and the cutting planes always cut the edges midway. So the front view and the top view looked identical, but the left hand side views actually showed the true shapes and dimensions. So we have completed these two examples. Now the third example, a cube cut obliquely by an inclined plane. So a cube can be cut obliquely by a plane which is neither parallel nor perpendicular to either of the primary planes. So this cutting plane passes such that it cuts the edges midway. 3 of the edges are cut midway, and this portion is actually removed after cutting. So this is called an oblique cut. So in 3D view we can see the cube with oblique cut. So this is the cube, and the oblique cut has created new edges. So basically one corner of the cube has been removed as a after sectioning. This is the isometric view of the cube after cutting. So the cube edges are still 40 mm, and the cut planes cuts the edges midway, that is at 20 mm. So now we will draw the orthographic projections of this cube which has been cut obliquely by a plane. So we will take this as the front view. This will be the top view, and this will be the left hand side view. So the front view will show these edges which will be there. The new edge has been created, and the front view will also show the projections of these new edges which are inclined on the front view. So the projections will be seen in the front view, and these projections will make basically a square with a new edge. So now we will draw the orthographic view. First, the front view. So we will draw a square of 40 mm sides. So this is the square and this inclined edge. So this inclined edge cuts two sides midway. So we will we'll find the midpoints of two sides. So this is the new edge which has been created as a result of sectioning, and this edge is visible in its true length. So now we will draw the top view. In the top view also we will see these edges. One of the new edge in its true dimension, and the other new edges will be projected. So their length will be reduced and they will be seen as a projected length. So this is a square of 40 mm sides. So these are the outer edges of the top view. And these sides are shown here. Now we will show the edge, the new edge that has been created. So midpoint of the edge and midpoint of this side. So we connect these midpoints together. So this new edge will be seen in its true dimension. And the inclined edge is projected. So it shows the projected length of the inclined edges. So now we will draw the left hand side view. A line at 45-degree angle. Now we will project the dimensions from the top view for the left hand side view. And then project the dimensions from the front view. So now we have these projections and we can identify the sides and the corners. So this edge in the front view and the top view represents the corner. and the other corner is represented by this edge in the top view. So these two corners have been identified. So now we can connect these two corners. So all other edges can be connected now. So this new edge is represented here. Now the inclined surfaces will be projected, so they will be seen as a projected length. So we will draw the projected length of those inclined new edges. So this makes the left hand side view of the cube. So in this example, the cube was cut by an oblique plane, and this oblique plane has cut the corner of the cube, and the new edges are seen in all the projections in the front view, the top view, and the left hand side view. So now we can do the dimensioning. So these are 20 mm each because the new edge is formed midway. These are also 20 mm each. And this side also, they are 20 mm each. Finally, the orthographic projections of this obliquely cut cube is ready. This is the three-dimensional view of the cube.